The problem is find the power of k size subarrays. So you are given an integer subarray, integer array nums, and a subarray length of k. The power of an array is defined as the maximum element of all its elements are consecutive and sorted in ascending order, which means you need to first of all traverse through all those subarrays present in the integer nums array, and you need to check one thing, that all the elements in the particular subarray are sorted and must be consecutive, and you need to return the greatest element in particular that subarray. So you need to return an integer array, and you need to place the particular greatest element of that particular subarray which satisfies this condition. And if the particular condition is not satisfied, you are required to simply place -1 at that particular index in our answer array. Return an integer array results of size n minus k plus 1, because obviously the number of sub-arrays created in the original nums array would be the size of our resultant integer array, where results I is the power of nums of I to I plus k minus 1. Right. Now, the constraint given in this question is up to 10 raised to 5, which means we need to do it in big of n. The particular solution that we would come up in our new approach is can be solved in this particular size array, subarray 1. Here the constraint was 500, which means we can do it in big of n square. And in this particular question, we did it with our naive approach, like traversing through all those subarrays, and we will be checking if this particular subarray is satisfying our constraint or not. And if that particular satisfies our constraint, we will return the greatest of that particular subarray, else return -1. But as we are given with a larger constraint and we are restrictive by using big of n square, we'll try to solve it in a little bit optimized solution. Now you will have noticed that we need not to traverse all those subarrays that we have traversed once again, because let's say you have traversed 1 2 3 index, and that particular follows our conditions constraint that are mentioned in our question. Then if the new element enters in our window, we just need to make sure that last particular index is should be greater, means that in nums of index plus 1 equals to nums of index plus 1, right? We need not to check again those numbers that we have already checked. And here we can, and here's where we can optimize the solution. So what we will do is, first of all, if k equals to 1, which means the subarray length is 1, we'll simply return the original nums array. And the other particular solution is, first of all, we'll find the length of nums. We'll initialize our answer result array with length minus k plus 1. That many particular subarrays are formed in original integer subarray. Now we will fill all the entries of our result array with -1. I'll tell you why we are doing this. And we will set consecutive count, which means consecutively this many number of elements are satisfying our constraint. As every each element individually obviously satisfies the constraint, because there is no other element in our subarray to check the constraint. So we'll initialize it with 1. Now we will traverse to our original subarray to length of -1. We will check if the next element of this particular index satisfies this constraint, which means it is sorted and is consecutive. Then we will increase our consecutive count, or else we will set it to 1 again. Now we will simultaneously check if this particular consecutive count is greater than or equal to k. Then at this particular index, what is this particular index? Index minus k plus 2. This particular index will be set by nums of index plus 1. This nums of index plus 1 will be our greatest element here, and this is the constraint that is followed, or else if the consecutive count is 1, we'll obviously not uh, place that particular index and it will remain -1. I'll tell you why it works. uh, Bring your attention towards here, please. If our window size is 3, which means first checking a 1, we'll check 1 with 2. Yes, this satisfies our constraint, which means consecutive count will be 2. Now in sliding window will be increasing. The next element encounter is 3. We will check it with this 2. 2 plus 3. 2 plus 1 equals to 3. Yes, this again satisfies a condition. So consecutive count will be incremented again. Next is 4. This will again satisfy. So consecutive count will be 4. So in 3 and 4, both will be satisfying our consecutive count greater than or equal to k. So in index 0, how is it 0? Index 2 minus 3, which means minus 1. Index 0, 1, 2, 0, 1, 1 minus 3, which is minus 2. Minus 2 plus 2 is 0. So in 0th index, our value will be updated to 3 from minus 1. Then the index will be 3, 3 minus 3, 0, 0 plus, sorry, 2 minus 3, which is minus 1 plus 2, which is 1. So at index 1 of our resultant array, the index uh, element minus 1 will be updated with index plus 1, which is 4, right? Now, as soon as the new element 3 is encountered, our current pointer is at 4, which means index is at 3. Now, 4 is not obviously 4 plus 1, which is 5, is obviously not equal to 3. So our consecutive count will be at 1, and hence the index will be remain with minus 1 entry field. And this will continue until our original num array is iterated over and the final answer result is been returned. Thank you.